everyone, myself Niyati Chauhan, Assistant Professor at LG Institute of Engineering and Technology, Department of Instrumentation and Control. Our subject is Industrial Data Communication and DCS. Chapter 4, System Integration with PLC and Computers. So in today's session, first we discuss integration with PLC. Here, need to just move information from a PLC to a DCS because the DCS has a better storage mechanism for production data. The information is passed to DCS for storage and totalization. The typical type of information exchange include actual running times for equipment, cycles or actuations for linear device such as some valve positioners. Then after next, person load a program, and when a product change is initiated, the DCS can download the new program into the PLC. This takes advantage of magnetic storage medium in the DCS and its capability to synchronize the downloading step with the analog changes being implemented in the process. Integration with computers. The historical storage capability of DCS, better than that of PLC, is still too limited. Very historical data bases in DCS system have a capability of storing only 32 to 72 hours of basic second by second information. If longer term storage is desired, it is often accomplished through the use of a computer-based process, management or process information system, PMS and PIS. This system collects snapshots of the process typically at 1 second to several minute intervals. So in this topic we have discussed integration with computers. Then after next, online storage of this variable is usually provided for periods ranging from several months to as long as 5 years. These PMS and PIS systems usually run on medium-sized microcomputers. In addition to the need to move into PMS, the DCS, there is also the need to move into the PMS information that has been generated by the PLC and passed to the DCS for intermediate storage. Typical information types in this category include running times, production statistics, and process measurement and set points. Then after next is integration with direct input-output. The first method of integrating PLCs and DCS and computers and also computers and DCS for high-speed application was to provide direct input-output connection to the each of the system. As shown in figure, PLC to DCS connection. We will discuss in next slide about this diagram. Then after next, this configuration creates a high-speed parallel connection which operate at the input-output scan speed of the connected device. In addition, it is actually desirable to include a circuit from each side which serves as a watchdog. So, this watchdog line is a pulse generator which turns on and off on a fixed time basis. Okay. Each side, PLC and DCS, monitor the line from the other device. So here you can see in this diagram, this is our PLC, right? And PLC connected with DCS system. Okay, so connector through we can connect PLC and DCS. You can see in this diagram. So here we are configured input output of PLC with input output of DCS. So how to integrate? So you can see in this diagram, right? So between DCS and PLC we have to connect connector, and connector through we can connect input outputs. Then after serial linkage. Serial data links are far more common between DCS and computers, especially where very high-speed communication is not essential to proper performance. Some PLC to DCS communication are also well supported by serial link, where the PLCs are only to provide information to the DCS for purpose of storage, or where minimal NMI related data is transferred. Serial links are the appropriate choice. So here you can see serial data communication. So first mark, right? So mark that means value 1 and space that means value 0. So 1010 form we are transferring our data. Okay. So here you can see at last even even parity bit means after 0 you can see 1111. So here our bit that is stopped. So this is a diagram for serial link transfer the data as sharing of pulses, right? And in this case the 8 pulses can represent 8 states of equipment operations. Okay. Next, network linkage. Between computers and DCS system, the limitation of the serial interface have been overcome by the adoption of a technology previously suited to wide area networking X25. Okay, so here network linkage, that is other name X.25. This is a standard for data terminal equipment DTE device to conduct multiple, if required, communication sessions with other DTE device over a network. It utilizes a packet switching arrangement. So here you can see in network linkage, right? Generally DTE devices do not talk to each other directly. So DTE device talk to data communication equipment. So here you can see OSI model that is shown on your screen, and here first in OSI model, first physical layer, then data link layer, network layer, transport layer, session layer, right, presentation layer and application layer. So here we are communicate, right, with our OSI model. Then after next, links between network TCP and IP. So here you can see in this diagram right? PLC connected with scanning, right? And here we have a communicate PLC with DCS and also communicate with real-time process image and tag database. Okay, so here we have a communicate with whole process. Then after next, here our chapter 4 is completed. Then after we will start chapter 5, field buses, map of network and protocol. So first we discuss computer integrated processing, CIP, manufacturing process involving chemicals, minerals and foodstuffs normally comprise a number of steps. For example, batching, mixing and reaction, drying, conveying, storing, all of which are individually controlled. Then after next is communication hierarchy. Figure show an example of a computer integrated processing data communication network. At the process or field level, information on process variable is gathered by sensor. Then after next, DCS type process control system and PLC act on this information to control the process by actuating valve, switching on pumps, etc. At the process control level, data from all parts of the process are brought together and presented to the operators at the engineer's console. So here you can see hierarchy of communication. So here you can see in this diagram, first field level, then after field level to device is connected with process control to production management, and at last company management. So in field level, we have a connected field buses, right? Then Profibus, then facility network, and at last company network. So here we have a communicate our whole system. So in this session, if you have any query, right, then you can ask me. Thank you for watching video.